Hello, this is an editorial for the problem Alice Likes Ice Cream from Photo War, April 2020. So the problem statement says that Alice likes to eat ice creams and only those ice creams are tasty which have their height in the range of L to R. It is even given that the height of each scoop is A units and we need to determine the minimum and maximum number of scoops she should add such that the ice creams are tasty. In case we cannot find an answer, we must be printing -1 and -1. Let's move on to solving the problem. What should be the minimum height of the ice cream such that it just crosses the value of L? Well, it will be the smallest multiple of A, which is just greater than or equal to L. Similarly, the maximum height will be the biggest multiple of A, which is just smaller than or equal to R. Let us take an example. We are given L is 5, R is 10 and A is 3. So what is the smallest multiple of 3 which is just greater than or equal to 5? Which is 6. Similarly, what is the largest multiple of 3 which is just smaller than or equal to 10? The answer is 9, right? So how many scoops each of height 3 we must add to have total height of 6? The answer will be 2. Similarly, how many scoops each of height 3 we must add to have total height of 9? The answer is 3. Okay, pretty simple maths. Let's move forward. Let's try to have a generalized formula. Let us say that we add k scoops to find the minimum height. Right. Now the minimum height will be k times a and this must be greater than or equal to L. Hence, the value of k will be ceiling of the value when L is divided by A. Similarly, say we add k prime number of scoops, then the maximum height will be k prime times A and this value must be less than or equal to R. Therefore, the value of k prime will be floored when R is divided by A. One thing we must keep in mind is that whenever we are calculating the value of k or k prime, we are only considering the value of one side. Say when we are calculating the value of k, we are only considering the value of L. We must also remember that the minimum height will be k times A must be less than or equal to R. Right, since it has to be in the range. Similarly, k prime times A must also be greater than or equal to L. Right, let's understand this with an example. Say we are given L is 13, R is 14 and A is 3. Using the previous formula, we can find the minimum number of scoops needed is 5 and the maximum number of scoops needed here is 4. Right. So the minimum number, what will be the minimum height? It will be 5 times 3 which is equal to 15. And what will be the maximum height? Which is 5 times 3, 4 times 3 which is equal to 12. We can see that 15 exceeds the value of R, right? This exceeds the value of R and 12 is less than the value of L, right? Hence the output will be -1 and -1. So what we can find from these two observations, the value will be -1 and -1 only when the total minimum height, when minimum height is greater than R and or the maximum height is less than L. Okay, so this is pretty much the logic. Let's code it. I will be using C++ here. So what we are doing here is that since we are given t test cases, hence we will be looping over the t test cases, right? And we have int L, R and A. So the value of K will be ceiling of L by A. Why am I multiplying 1.0 to this fraction? To convert it to a floating point number, we must provide the ceiling function must be provided with floating point numbers, right? And K1 will be just R by A since this is the float value. Okay, so what will be the maximum height? Maximum height will be K1 into A, and minimum height will be K times A. So in which case the answer will be -1 and -1? If maximum height is less than L or minimum height is greater than R, then the answer will be -1 and -1. Okay. If this condition is not true, then we will simply output the number of scoops. Okay, it's done. So let's take the examples which we discussed now. Okay, done. So we can see that this is the answer and this is definitely the correct code. So that's it. Thank you.